Okay, today we're going to be talking about piecewise functions. This is just an introduction to piecewise functions, so we're going to be focusing on reading and evaluating piecewise functions today. Here's the definition. A piecewise function is a function that combines pieces of different equations or graphs. Each piece is for a different domain or set of x values. We have three examples pictured on the bottom of this slide. The first example, we have three different pieces of graphs together in this piecewise function. The blue is a linear function, the red is a constant function, and the green is a nonlinear function. The next example, we have two pieces of linear functions written out in function notation for this piecewise. They are specifying the domain. If x is less than 0, then we're following this function. If x is greater than 0, we're following this function. Okay, and the third example is another graph. We have a constant function in red, a quadratic function in blue, and a linear function in green. Okay, so we are going to evaluate some different values for this piecewise function. The first one, f of 2. We know the input or the x value is 2. So I'm going to go on the graph where the x value is 2 and figure out what is the output? What is the y value? Looks like that y value is 4. So when the input is 2, the output is 4. The next example, we have the input is 0. So again, the x is 0. I want to know what is the y. The y value or the output is like 1. And the third example on this slide, we have the input is -3. The x value is -3. We want to know what is the y. Looks like the y value is -1. Okay, these next three examples, we do not know the input. We do not know the x. We're supposed to find x, but we know the output is -2, or the y value is -2. So I'm going to locate where the y value of -2 is on my graph and figure out what x value is that associated with. For this one, x equals -4. So when y equals -2, the x equals -4. Says find x when f of x equals 0 or y equals 0. Here is where y equals 0. If I locate the x that's associated with that, x equals -2. Third example on this slide says find x when f of x equals 1. My y value is 1. I want to find the x values that are associated with it. Notice I have more than one x value associated with that y value of 1. The first one starts at -1, the next one 0, and the third one 1. But notice these points, all three of these points are connected. So really, it's any value between -1 and +1. I'm going to write that as a compound inequality. So -1 is less than or equal to x, which is less than or equal to 1. Or in interval notation, from -1 to 1, including both of those values. Okay, here's a U-try. So new graph, new piecewise function over here. Take a look at these 7 questions and see if you can evaluate the questions for those x and y values. Pause the video and then unpause to get the answers. Okay, here are the answers to those 7 questions. I want to spend a little bit of time talking about number 3. If we take a look at the graph, f of 2, that is telling me when x equals 2, what is the output? What is the y? Notice I have an open dot there. So that means there is technically no y value associated with an x value of 2. So it's the empty set, or no solution. I'm also going to focus on number 6. It asked me to find x when y equals 3. If I locate where y equals 3 is, notice I could go to the left or to the right to get x values that would match that y value of 3. So those x values are -1 and +1. So we get 2 solutions there. X equals -1 and x equals +1. Okay, the next set of examples we're going to take a look at is function notation of a piecewise function. And again, we're just evaluating these. So when x equals 2, I need to decide what domain does that fall within. If x is less than 0, then I would use the top function. If x is greater than 0, then I'm going to use the bottom function. So my x value is 2. So that would be x is greater than 0. So I'm going to use the 3x minus 3 equation. So 3 times the x value of 2 minus 3. That gives me 6 minus 3, which is 3. The next example, we have an x value of 4, -4 rather. So again, looking at my domains, is x less than 0 or is x greater than 0? For this one, x is less than 0. So I'm going to plug it into that top equation, -x plus 2. So the opposite of my x value, -4, plus 2. The opposite of -4 is +4, plus 2 gives me 6. The next example, we want to find f of 1. If I look at my domains, is x less than 0? No. Is x greater than 0? Yes. So I'm going to be using this bottom function again. 3 times the x value of 1 minus 3. 3 times 3 is 3, minus 3 gives me 0. The next example, f of -2. If I look at my domain, is x less than 0? Yes, I'm going to be using this top equation. So the opposite of my x value, -2, plus 2. The opposite of -2 is +2, plus 2 is 4. And then the last example we have f of 0. Is x less than 0? No. Is x greater than 0? No. So notice there's no part of the domain that includes 0. So this one is no solution, the empty set. We are also going to be finding x values when we're given outputs. This one, f of x is equal to 0. So the output is 0. Notice we have 2 domains. So we're going to have to solve 2 equations here. If x is less than 0, which I don't know at this point, then I'm going to use the top equation. -x plus 2 would equal the output, and my output is 0 for this. Okay, if x is greater than 0, then I'm going to use the bottom equation. 3x minus 3 would be equal to the output, again, of 0. We're going to solve both of these equations. So in this first equation, I'm going to subtract 2 from both sides. I get -x equals -2. Divide both sides by -1, and we get x equals 2. Checking the domain, x is less than 0. I got x equals 2, so no, that is not part of my domain. So I'm going to throw that one out. Solving this equation, I'm going to add 3 to both sides. We get 3x equals 3. Dividing both sides by 3, we get x equals 1. Checking the domain, is x greater than 0? 1 is greater than 0, so yes, that is a solution. All right, another example similar to the first, we want to find x when f of x equals 3. Again, I'm going to form my two equations. When x is less than 0, I would be looking at this top function. Negative x plus 2 would be equal to the output of 3. If x is greater than 0, then I'm looking at the bottom equation. 3x minus 3 would be equal to the output of 3. Solving both of these equations, I'm going to subtract 2 from both sides over here. Negative x is equal to 1. Dividing both sides by negative 1, I get x equals negative 1. Checking the domain, is x less than 0? Yes. So x equals negative 1 is a solution. My second equation, adding 3 to both sides. 3x equals 6. Divide both sides by 3, so x equals 2. Checking my domain, is x greater than 0? Yes, 2 is greater than 0. So another solution is x equals 2. So this one has two solutions. Okay, the third example, we are finding x when f of x equals negative 3. If x is less than 0, I am looking at the top equation. Negative x plus 2 is equal to the output of negative 3. According to my second equation, if x is greater than 0, then I'm looking at the bottom equation. 3x minus 3 is equal to the output of negative 3. Solving both of these equations, over here I'm subtracting 2 from both sides. Negative x is equal to negative 5. Dividing both sides by negative 1, and I get x equals 5. Checking my domain, is x less than 0? No, 5 is not less than 0. So that one is eliminated. Adding 3 to both sides over here. 3x equals 0. Dividing both sides by 3, x equals 0. Checking my domain, is x greater than 0? Well, no, 0 is not greater than 0. So there is no solution to this one, or the empty set. Okay, the last example is a you try. So take a look at these 6 questions, pause the video, and then unpause to get those answers. Okay, here are the answers to the first 5. Okay, I'm going to go ahead and walk through the last one together. We have the output, the y value is 91. We're finding x. So if x is less than or equal to 5, I would have the first equation, negative x minus 4 is equal to the output of 91. If I use the second equation, 5 is less than x, which is less than or equal to 10. I would use 2x squared minus 7 equals 91. Solving both of these for x, we add 4 to both sides. Negative x is equal to 95. Dividing by negative 1, x equals negative 95. Checking the domain, is x less than or equal to 5? Yes. So negative 95 is a solution. Solving this second equation, we add 7 to both sides. 2x squared equals 98. Dividing both sides by 2, x squared equals 49. To get rid of that square, I square root both sides. X equals positive or negative 7. Checking my domain, only the positive 7 is in the domain. So x equals positive 7 is a solution. The negative 7 is not. So I get two answers, x equals negative 95 and x equals 7.